Good evening, ladies and gentlemen. A very warm welcome to all of you to today's guest talk and discussion on ancient irrigation systems in Sri Lanka and their modern development, organized by the Water Forum of the Institution of Engineers Sri Lanka. Sri Lanka is a country blessed with a proud and remarkable history of irrigation engineering that spans over thousands of years. As we all know, these days, there are many discussions happened about these ancient irrigation systems as we have already faced a disastrous situation due to a cyclonic high rainfall. This evening, various important themes regarding ancient irrigation systems will be explored and connected by a highly experienced professional in the field. Our speaker for today is Engineer Palitha Manchanayaka, whom I will formally introduce a little later. At this significant moment, we extend a most cordial welcome to our esteemed guest speaker, all respected invitees, and every participant present here today. To formally commence our proceedings, it is my distinct honor and privilege to invite Engineer Janaki Migastanna, the distinguished chairperson of the IESL Water Forum, to deliver the highly anticipated welcome address. Engineer Janaki, Madam, the floor is yours.
Thank you, Lahruni. Good evening, ladies and gentlemen, and a warm welcome to everyone joining us here at ISL and all participants joining online via Zoom. Today's guest talk on ancient irrigation systems in Sri Lanka and their modern development brings together the remarkable journey of Sri Lanka's water civilization, spanning from ancient hydraulic engineering to the challenges of the present day. Our irrigation heritage begins in the Malvatue Basin, where early kings established their capital in Anuradhapura. From 500 BC to 700 AD, this era witnessed the construction of 1,000 reservoirs and the evolution of sophisticated hydraulic technologies. The legacy moved into the Polonnaruwa era up to about 1200 AD, where large-scale systems such as Parakrama Samudra exemplified the maturity of our hydraulic civilization. Across this era, remarkable interventions emerged to Bisokotuwa, Katasorowa, and the procession in Kalaweva Yodala, built by King Datusena. These innovations demonstrate continuity and the refinement of engineering intelligence that modern hydrologists continue to study. Moving into the colonial to post-independent period, Sri Lanka shifted towards the rehabilitation and modernization of ancient systems. Yet, we also learn hard lessons such as disruption of small tank cascade systems during during the Mahavali development program, reminding us that ancient designs were environmentally and socially interconnected. Today, we understand in the uh, facing new and complex challenges, recent extreme events, including severe cyclones, intensified floods, and prolonged droughts, have tested the resilience of our water infrastructure more than ever before. These events underline the importance of understanding traditional systems, integrating them with modern science, and strengthening climate preparedness. Finally, our decisions will connect these historical eras to the modern Mahavali reservoir systems, a vast interconnected network serving irrigation, hydropower, and interbasin transfer, showing how ancient principles still guide present day engineering. We are honored to explore these themes with the guidance of an experienced professional in the field, Engineer Palitha Manchanayaka, whom introduced shortly by Engineer Lahiruni. Thank you once again to all our Zoom participants for joining us. I wish you all a meaningful and insightful session. Ladies and gentlemen, thank you once again for being here. I wish you all a productive and enlightening session. Thank you.
Thank you very much, Engineer Janaki, for the warm welcome. Now, it is my honor and pleasure to introduce today's distinguished resource person. Engineer Palitha Manchanayaka received his education at Royal College, Colombo, and graduated with honors in civil engineering from the University of Ceylon, Peradeniya in 1972. He joined the irrigation department as an irrigation engineer and served as a construction engineer at the Wahalkadawava Reservoir project in Anuradhapura district, restoring an abandoned ancient tank. In 1976, he obtained his professional qualifications as MICE London and Chartered Engineer. He earned his Master of Engineering Science degree in hydrology from the University of New South Wales, Australia in 1981. From 1983 to 1987, he served as Assistant Director at the Water Management Secretariat of the Mahavali Authority of Sri Lanka. During the same period, he was also a visiting lecturer in hydrology at the University of Moratuwa, a consultant and unit author at the Open University, and a national consultant for ILO UNDP in establishing the Technical Training Institute at Katunayaka. He received the prestigious Ceylon Development Engineering Award for the best paper published in the Engineer Journal during 1984 to 85 and is a fellow of the Institution of Engineers, Sri Lanka. He co-authored the book Water Resources of Sri Lanka in 1999 and later published Memories of a Water Engineer in 2022, capturing over 50 years of professional experience. After migrating to Australia in 1987, he served as a hydrologist at the Commonwealth Bureau of Meteorology, Sydney, for 20 years until his retirement in 2008. In 2018, he delivered the prestigious Professor E.O.E. Pereira Memorial Oration on Water Resources and Hydrological Forecasting at the IESL. Ladies and gentlemen, with great respect and pleasure, I invite Engineer Palitha Manchanayaka to deliver today's talk on irrigation and ancient irrigation systems in Sri Lanka and their modern development. Sir, the floor is yours.
Ladies and gentlemen, thank you, Larry, for the introduction. And Janaki, I must be thankful to Janaki for arranging this lecture. Thank you. Now, I will start with this. This is a Tamanna beach, possibly where Prince Vijay landed with 700 people from North India. Actually, he came, and this is my guess. I guess it should be. Now, word Tamanna is not being used today, so it's not used today. So I guess Tamanna is Tamanna is actually just near the south of Mana, I guess. And this is Malvatuya. That's Malvatuya, originating from Kritikala, and it's going past Anuradhapura, and the Nachadua reservoir is dammed by it's across Malvatuya, and then it joins the giant stand, the Yoda River in Mana, and it falls to the sea. By the time it falls to the sea, it changes its name, Malvatuya. We change Aruviaru. Aru means oil. So that's Aruviaru. So Tamanna is somewhere there. Then Prince Vijay landed with 700 people from India, and the pond. Now what happened was these guys have been traveling by sea, and they were thirsty for water. So thirsty for water, and now Prince Vijay sent his men to say, look for a source of water. And none of them returned. Then Prince Vijay himself went in search of water. And he found a pond beside which there was a tribal queen by the name of Queni. And she was knitting, doing knitting. And then apparently the story goes that Prince Vijay got friendly with Queni, and eventually he captured the kingdom and all that. But my interest is about the pond. The pond, late Mr. Manamperi, HDS Manamperi, the former director of irrigation and first chairman of the MDB, Mahaveli Development Board, and he was of the view that this pond is not a natural pond, but an artificial one. This point actually interested me, and I studied the rainfall patterns and the evaporation records of Mana to see that, and that's what it is. And I'll show you. What happens is we measure the pan evaporation. Now, pan evaporation, you have to measure according to world standards, WMO, where it should be 3 feet in diameter and 10 inches of water and blah, blah. So we measure the pan evaporation, and from there, we will be able to estimate the lake evaporation. So these are the monthly lake evaporation. And then I managed to get the long-term average rainfalls of Mannar. This is what it is. But what really interests me is this particular, from October to December, the rainfalls, the heavy rainfalls are there. And month of June, the monthly evaporation is 134, and the average rain is only 5 millimeters, and the number of rainy days is just one. And then July again 126.7, like that. So, and the evaporations are quite high. And if I put it in this diagram, if we can see the rainfalls are, this is the rainfall. That's only October to November. And the rainfalls in June, July are very small, hardly any. And these are the evaporations. The blue color is evaporation. And this shows that to survive, the Yakshasha tribe, to survive in that area, they should have had a very good knowledge of water conservation techniques. So I think Mr. Manapiri's view, I don't know whether he did a study, but his view is correct. That's what I believe. So the Kuenis Yakshasha tribe they would have had a very good knowledge of water conservation techniques to survive in the area. And furthermore, I could add that now the Vilpattu is Pattu in Tamil, it's Ondurendu Mundu Nalu up to 10. The Pattu is 10. So Vilpattu, those are again natural, not natural lakes, but man-made ones. And this is the palace of Kueni. I managed to get something, some photos, palace of Kueni at Kalivillu inside the Vilpattu Park. This is again another view of some other remnants of Kueni's palace. And possibly this is the burial place of King Vijaya. I don't know. This is just a guess. Then coming on to the dams, all dams of Sri Lanka are now, before that, I must tell you, King Vijaya reigned from 483 to 445 BC before Christ, 38 years. And he did some work. He constructed small ponds and small diversions. That's how he continued. And now coming on to dams, all ancient dams are essentially earthen dams. Now, this is actually the Basavakulam Weber built by King Abhaya in 400 BC before Christ. First ever tank in the world, actually. And Tisa Weber, King Devanampi Tisa, 200 BC. And then I think Dutukamuni is somewhere here, 102 BC. The Dutukamuni period is somewhere there. And King Mahasena, 300 AC, Mineria, all these Mahasenas. And then further down, we have this Parakma Samudra in 1170. It's out of the board. And now this is the collection. Basavakulama, length of the band is 0.75 miles. Height is 16.5. Tisa Weber, this much. And going on, Parakma Samudra has 9 miles long. It's out of the way. But Kaudulla, that is Kaudulla, 6 miles long, like that. Nura Weber, 4.5 miles. There is Nura Weber here, 4.5 miles. Okay. Now, these, I must tell you that irrigation department started as a subgroup under public works department, that started in probably 19 not 19 not and then established itself as a full department. And up to 1954, all the directors were, you know, Watsons, Taylors, and all this, the British. And the first director irrigation was, Sri Lankan director irrigation was Mr. W.T.I. Alagaratnam. And people say he is referred to as, sorry, he is referred to as Walk to Infinity Alagaratnam. That is, if you go with him for inspections, he'll go to the very end, it seems. So junior engineers can't walk with him. So, and the people have named it Walk to Infinity Alagaratnam, W.T.I. Alagaratnam. And now, now irrigation department, all what they did was restoration of the breach section. So that ancient, all these reservoirs, one day or other with a major flood, they have gone off. And there's a breach section, maybe something like 30 feet high and length of 600 feet or 600 meters or whatever. So what they did was only the breach closure, only the breach closure. But what happens is, now irrigation department, we have our soil testers, you know, we go with the modern soil mechanics. So we have to find the correct soil, and the soil testers go and look for borrow area surveys. And because we need for core trench and all that, you need the proper clay and things like that. And then they do the in situ measurements, and in situ measurements, and we want to go for the maximum dry density, so that the soil particles are touching each other, so that the water won't pass through. So in order to do that with modern our soil mechanics, we have to go for the optimum moisture content. We draw a curve and get that. So that is how we do it. But what happens is now Parakma Samudra has 9 miles long bund. So the breach was done by the present day soil mechanics people. Okay, we are sure of that. But once the reservoir is impounded, the king's soil mechanics is under threat, because we don't know how the king has done it. He would have been using cattle, elephants, or whatever, or he would have given, say, so many miles now, 6 miles long bund. They give certain speech to a certain village or whatever. So probably village, I guess, village hitman or somebody may be supervising. But the problem is, if there's some sort of lack of quality, once the reservoir is full, if it breaches, because we are sure of our soil mechanics, the present day, but the king's, it's under threat for all that. So if it fails, that's what it is. That's the problem. But I should say, this one, this is Mineria tank. Mineria tank, I was told that this has never been reached, and it has served probably 1,700 years, every Yala and Maha, if that is correct. But now King Mahasen, who had done this, he's treated as a deity, as a god, and people still respect him. And if you go to Polonnaruwa on the way right, you come across Mineria tank, and it has 1.5 miles tank bund. Please, if you haven't been to that place, please take a drive on that tank bund. There is every, what they call Kemmura Davas, every Wednesday and Saturday, they make offerings to Mahasen Deja, right? And take a drive. It's quite scenic, you know. This side the lake, the Parakwas, Mineria Lake, and other side you have the giant sluice and all that. It's an amazing feeling you have. So please take a trip to that. Now I like to get on to this Sorabora thing. Sorabora, this is what the inscription of Irrigation Department is, and it has been built by Bulatanam Yode. So I don't know whether he's really a giant person or I don't know, whatever it is, the story goes that this guy has been living in during King Dutugamanu's time, that is 102 BC, and he has apparently done this, and it has been off somewhere Mahyangan area in a bushy area where it was, what I hear is it's a type of a jungle inside the jungle, and the King Dutugamalu hasn't come to know it, and suddenly this guy has completed, him and his crowd has completed the reservoir, and he's supposed to have invited King Dutugamalu to open it, and then, because then the name Sorabora, as they say, so Sorensa Burueng Karpunisa Sorabora Kila Kino, right? But now this one is a small tank of capacity 11,800 acre feet and irrigating about 1,700 acres of paddy. But what is interesting is it has this rock cut deep canal acting as a sluice at Sorabora. So it is actually a 2-foot diameter opening sluice is the thing, and that's the first of its kind, this type of thing. And the reservoir and the structure has been declared as an archaeologically protected monument. Still functioning well, served the nation for 2,100 years. Now, getting on to another one, Sri Lankan invention of Katasorovo. It's a masterpiece of innovation by the ancient Sri Lankan irrigators, and it has been in good use and continued over the past 20 years. Discovered around 400 to 300 BC. Now, this one, I'll talk about it. Now, the British, after 1815, when they were roaming around Sri Lanka, they would have come across this Katasorover, and then they have realized the phenomenon of what it is, and then they named the same as that Katasorover is nothing but morning glory Pilkum sluice. That is actually, this is Katasorover. This is Katasorover where when there's a village tank, there's a clay pipe running across of 6 inches or 1 foot or whatever, and then from the tank side there's a thick collar. On that collar, we could keep that what you call kate. Kate is about 1 foot high, and with a thick collar, you can see this thick collar. So as the water level rises, you add another kate, right? Go on, and up to the man's height. And at the top, once the reservoir, once it is full and going down, you take the topmost kate, then water spills over and it acts as a sluice. So spill cum sluice. Amazing. So this was done in 400 BC, right? So this is a close-up of the Katasorover. Now getting on to, that's for small heads, Katasorover was for lower heads, but for high heads of about, what happened? I have to, excuse me for this. Yeah. Now, this is an excellent innovation by the local engineers at that time, and introduced during King Wasaber's period, that's 67 to 111 AD. And this is the sketch of Misopotua. This I managed to get. This is from Henry Parker. He was an irrigation engineer, British, and he has published a book, Ancient Ceylon, in 1909. And this is, he had got this sketch. but no one knows exactly how it was operated. So RL Spittle, no, not RL Broyer, RL Broyer, sorry. RL Broyer did a lot of, but he's basically a surveyor. But he was trying to figure out how it operated, but he has written books, but no one knows how it is operated. But some people believe it was over a pulley and it's being pulled by elephants, but all that. But whatever it is, there's that. There's a sort of a double barrel there and merging as per power to pull through. Now, this is where I had my charter training. Wahalkada is, for those of you who don't know where Wahalkada is, it's about 50 miles from Anuradhapura, 30 from Madhavachia, 30 from Vaudia, 17 from Pulmudebu Beach. And this was an ancient dam built by King Mahasen, and it was abandoned. And the late Mr. Maitapal Senaka, who was the Minister of Irrigation around 1970 to 77, he was very keen to have this because it was in Maitapal's electorate, and he wanted to do abolish the overseer system, and he wanted to introduce the direct labor, and he basically wanted to give his people, unemployed people in Madhavachia, employment to cut the channels manually. So that's how it was done. This is the Wahalkada sluice. That's interesting because now it has been functioning for some time, and it has been abandoned because of some major flood. The tank portion of the tank one would have gone. So the Tavalang Halmil Lab Oya is where the dam is. It is a tributary of Yana. So that water won't be stored there because of the breach. Water was draining down, so no reservoir. So what we did was we did the breach filling at Wahalkada, and it's all jungle, you know. Then irrigation department, we have this what they call survey maps, right? With these maps, the irrigation engineers, we decide this is where we are going to have the sluice, right? But there's a little criteria involved in this, where to locate the sluice. That's it has to be the highest point of the irrigable area, because irrigable area is there. So it has to be the highest point of the irrigable area because it's going to feed water under gravity. Right? At the same time, it has to be the lowest point of the tank bed area, because if it is not the tank bed, there will be a dead storage. Dead storage is useless. So this is the thing. So with our irrigation engineers locating where to have the sluice, we decided, and our irrigation people, they started digging up to establish the new sluice there. To see, we found the old sluice there, very same place. So that means our ancient irrigators have known for them to have the same location, but we couldn't preserve it. We couldn't preserve it. It was in pieces. But at the same time, Maduroya, when they dug up, they found the old sluice. I'll give you a picture of that. And then they managed to preserve it. And they shifted the sluice to a nearby place, and they went on. This is a channel out from our Wahalkada sluice. This is the preserved Maduroya old sluice. Apparently, this is a double barrel thing. And how it was operated, we don't know. We don't know. We are yet to investigate. Right? We are yet to investigate, and there are these stone, all that is neatly cut, and all that. So it's very people. There's a lot more to study on it. Now let's go on because I limited time. I'm just touching on Yoda Allers of Sri Lanka. at least there are 5 Yodalas in Sri Lanka. Yodala, Kalawava Yodala, we call it KYE. Alahara Minedia Yodala, EMYE. Minedia Kantala Yodala, MKYE. Angamadila Yodala, AYE. Minipe Yodala, MYE, the military left there. Now, Kalawava Yodala was built by King Dhatusena at 470 AD, and it's a canal joining Kalawava to Tisawava in Anuradhapura. Yeah. So I'll come to it in detail. But next one, Alahara Mineria Yodala. It was Alahara Mineria Yodala was by damming, having an anecut at Amandaga and taking water. It was built by King Wasaba in 100 AD. And this Alahara Mineria Yodala, after 20 miles, we come to the bifurcation structure, what they call the Dia Beduma. Dia Beduma, I'll show you a picture of it. Dia Beduma is to divide flows to Giditale and Mineria. In Mineria Kantale Yodala, when Mineria gets the water, some water is being sent to Kaudulla, which is about 15 miles away. And this was, it was built by King Mahasen at 300 AD. Now, and Mineria Kantale Yodala takes water to Kantale, and this was built by King Agabodhi the first at 600 AD. And Kantale, it's to feed Kantale tank, and it's about 20 miles of channel work. And further, it's been Vendrasan, another canal, another reservoir is being fed. So Kantale and Vendrasan. Angamadila Yodala is a short one, 4 miles. That is again damming Ambangaga to augment Parakram Samudra supply. Parakram Samudra itself has about 28 square miles catchment, and this is with Angamadila Yodala be catering for the needs of Parakram Samudra. Parakram Samudra, it was built by Parakram Bahu the first at 1170 AD. And yes. Then this one, Minipe Yodala, Minipe LB, it was built by King Agabodhi the first at 600 AD and going for 17 miles. And further, King Sena the second at 80 AD extended that to 47 miles. Okay. Now, talking about these ones in detail, that's famous Kalawava Yodala. And as you could see, that single bank in canal, and it could accommodate all the inflows into this. This was built by, as I mentioned, King Dhatusena in 470 AD, 52 or 54 miles, I don't know, from joining Kalawava to Tisawava. An amazing gradient of 1 foot per mile. Those days we did it in imperial units, 5,280 feet is 1 mile. So 1 upon 5,280, easy calculation, if you call it 1 over 5,000, it will be 0.0002. So we can't get these gradients with the slope from our survey equipment. We would go for the second decibel or probably third, I don't know. But now they say this KYE, the first 17 miles, the drop was only 6 inches per river mile. When you work it out, it will be 0.0001. Amazing. So this is a single backing channel. Oh, I just. The main thing is it's a single banking channel and traveling along the contour line. And KYE takes it can accommodate the intermediate flows, and anything in excess would spill over, and there'll be a system, and feeding many more village tanks, right? But on the contrary, the Jayaganga, which Mr. Jaya Jawardena and our Minister Kamini Disanayaka did in the 80s, it's a double banking channel. So sorry. That's what it is. It's double banking channel and it can't accommodate any intermediate flows. Whatever that is being released from this sluice is going down there. And it's actually, it's going across the contour lines, whereas in the previous one, it's going along the contour lines. And a word about back on this. How they did this amazing gradient was by a technique called series of Amunu Gilma. That's the word, Amunu Gilma. Amunu Gilma, they say Gilma Gahanoa. Gilma Gahanoa is actually you join the Kalawever to the nearest closest village tank and single banking and hold it. Like this is the guess, how they would have constructed. And then there's one single level pool. And then you join it to the next one. And like that, it's one single pool all the way from Kalawever to Tisawever, right? And this Gilmagahanoa technique, they say it's at, now Parakul Samudra has 9 miles long tank one. That's again, three reservoirs are being linked. That is Topa Wever, Eramudu Wever, and Dumutulu Wever. That's the same technique. And furthermore, Professor A.V. Suravira of Jayawardhanapura University in Rajavaliya, he has said during the Kotte period also, the contour channel surrounding the king's palace was also built by the same Amunu Gilma technique. That's the Jayaganga. This is Alaharabineri Yodahara that has existed for whatever the period. Okay. This is the Diyaveduma, the Alaharabineri Yodahara. That structure is for to divert water to Giritale. If Giritale doesn't want it, they'll be shutting down the gate. All that flow along EMY will be going all the way to Nimeria. Now, getting to this one, it's a fairly interesting story. How the British demolished the irrigation reservoirs and village tanks in Uwa Vellasa during the 1818 rebellion. I actually studied this. I studied it, what happened. What happened was, let me take this time, I'll try to run through it. The Candian Convention, now the chieftains of Kandy, they signed the agreement in 1815 with Robert Brownrigg, the governor, and they went on. And now 1818, by about 3 years, the chieftains of Kandy, they realized that the British have taken them for a ride, right? They are not adhering to the promises that the Candian Convention that they have signed. Then what happened to it was further to, it got worsened because the Muhandiram of Vellassa, Kohukumre Raterala, he was the Muhandiram of Vellassa. He was removed by the British government and they appointed a new person, Haji Marikar of Malay ethnicity. And that Haji Marikar went to collect the fees, right? Funds of the taxes. Then what happened? Kohukumre Raterala came with some people and killed him. Then what happened? This was under the jurisdiction of Sylvester Dias Wilson, AGA Badula. It was under AGA Badula, by the name the Sylvester Douglas Wilson. That guy apparently hasn't taken it so seriously. He has heard that Haji Marikar had been killed. So he came with about 10 people and he had come to Velasa, stayed the night there. He has said he'll investigate it the following morning. In the night, Kohukumbre Raterala has come with the crowd and killed all of them. Then what happened? The Britishers then only realized the gravity of it. Then how to overcome this? Brownrigg was very angry, Robert Brownrigg. Then, now by that time, Sri Ahlepola Adhikarama has fallen out with Sri Vikramaraj Singh, and you know the story, Madhu Mandara and all that. Not Viharamaddevi, over there. Ahlepola Kumari Hami was drowned, tying a big, these are the stories we heard from young days, tying a stone to her tummy and she was made to get drowned in the Candy Lake and all that. But this guy, Ahlepola, moved to Colombo and he's the one who gave instructions how to get to Kandy. But earlier, what happened when the British were coming, these fellows, Kadugan now, Balana area, they'll roll some rocks and all these techniques, they couldn't pierce through. So Ahlepola was instrumental in making access way for the British to get to Kent. And then Ahlepola thought once the king was removed, British would appoint him as the king, or he had the control. But what the British did was they dispatched him to Mauritius Island or something, and poor fellow died there. So right now, Ahlepola Kumariami's brother was Monaravila Kapatibola. He was in charge of Matale area, and he's Ahlepola's brother-in-law. So the British government thought best man to crush this rebellion at Ua was to pick this guy. They called Monaravala Kapatibola Disawa and send him with the army to crush the rebels. Right. Then Kapatibola went there to Ua, and before starting the fight, he has asked the guys who are rioting, what's your problem? Then they said, 1815, these guys are not adhering to the conditions they agreed to, and they have taken us for a ride, blah, 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 all this. And Munragala Kapatibola was convinced. Then what he did was, he joined the rebels, and he called his number 2, the British guy of the troop. He said, take all these weapons, return back to Colombo. I'm joining the rebels. Then everything went. British Brownrigg was so angry, Robert Brownrigg, governor, he ordered to crush this. We know Uva Vellassa was a very prosperous area, They say Vellassa means Vellaksha. That means 100,000 paddy lots. And what happened was we had this one village, one tank, one village ecology. That means we had the tank at the top and downstream, we have the paddy lots and the homestead. So when rains come, they get stored up, and with that water, they utilize that for cultivation. What Brownrigg did was to give the order to kill, merciless, kill all male population above 15 or something. And we have all these, now we have cattle and all, kill them, Harakabana, all that, kill them, merciless hammering, destroy all the tanks. So all these abandoned tanks, multitude of tanks were all demolished. And now if you take 1 inch to a mile survey topo sheet, you can see thousands of tanks in Vellassa. They demolish it. Then what happened? Rains come, water won't be staying there. So the farmers can't live there because no water. They have to leave. So they deserted Vellassa and moved to other areas. other areas. And so with that, uh, with that, uh, with that, they crushed it. But the capital and them they were fighting for nearly 1 year, and eventually Capitol was caught, and Captain O'Neill or somebody surrounded his house, and then the story goes that Capitol came out and said, owned up that he's Capitol, Capitol, and he surrendered, and him and Madugalla Disave were and few others were sentenced to be beheaded. And then, in fact, the story goes that Capitola at Candy, going to Maligawa and all that, and read Dhammapada, all this, and then said he has requested the guy who is beheaded to go for one hit, but apparently he missed it and done it in the second stroke. I was told. Anyway. Right. That's that. What else can I say on this? Yes. Now, the important. British were very angry. Were really angry with Vellasa, and with that they didn't want to. Do any infrastructure development. They didn't want to do any infrastructure development from 1880 up to 1948, 130 years. No infrastructure development was done. And they did the train line to Badulla, that's to transport their tea. But other than that, they neglected it totally. And then that was it. And it became a barren area and most, poorest type of province in country, unattended, no, all that. And in 1970, the Sirimau Bandanaya government came in, and with Maitripala Senanayake as the Minister of Irrigation, he started what they call the Lower Ua Development Program, Pahala Ua Samvardhana Yojana Krame, and of which now he demolished all the village tanks, and there were about 2 or 3 bigger tanks like Mutukandi and Ramukanoya. And what happened was, I graduated from university and I joined the planning branch of irrigation department, and under Mr. Jerry Gunawardena and also Mr. Gunawardena. And they gave me the job to do the feasibility studies, carry out from scratch, carry out the feasibility, do the feasibility studies, and prepare the feasibility reports for Mutukandi and Ramukanoya. I was a raw graduate, and then was given a senior TA, DV Vijayasiri. We started off in a 4-wheel Jeep, Hendrik the driver, and we had to find the dam site. No roads, and we went to Mahoya. So Mahoya, it's another story. Mahoya is where in 1930s, Dr. R.L. Spickle has been a specialist, but he was interested in Vedda, the wildlife, and he took up the post as DMO Mahoya, and he had been visiting Tisahami, and that's how the story. And he talks of wild white boy, savage sanctuary, and all these stories are Suduhura and all that. So he used to visit these Vedda villages, and now we have to get there. No roads. So Vijayasiri, my the senior TA who was helping me, he went around the Mahoya and spoke to few people and said, "Apite andone dam site Vaukandia, Kadita Vaukandia Balan." He said, "Dahagani answer." He had a gun. I think it was an unlicensed gun, but the fellow was aware, and he said he took us, and we said, "You better be with us for 1 month." And he was paid 760 a day. That's a casual wage of a casual employee. He was with us, and he took us. And now he says, or he took us. And there's we were facing wildlife like bears, elephants, deer, everybody there, and but we had only that man as the gunman, and we found the dam site, and we had to do bedside tank bed surveys and all these, how much the breach is and how to do it and all that we were doing it. And while doing that, there were Vedda villages like Nillobe, Pollebadda, Kuruduvinna. These names come in Dr. Spittle's book as well. So Vedda villagers, actually, we had the incident where there was a school. There were 40 students in the school, and the headmaster and his wife were the only teachers. They teach from grade 1 to grade 8. And what happens is Ramukannoya, now the famous Ramukannoya, but in irrigation books and files, they say Ramukannoya. But at the time, once it was built, they changed the name for Ramakannoya. So I don't know how they changed the name, but all the irrigation maps and everything, files, all the records, they say Ramukannoya. So I'll talk about the Ramukannoya. What happened was the principal, he says, the headmaster, he says every month of October, it floods, Ramukannoya floods. And the school is at the hilltop. And what happens? They get marooned. And even the Vedda people, they bring pots and pans and they stay there for 2 weeks. All this, right? And once the rain, the flood recedes, only they go back, right? So it's a very backward area. So, right. And in one of those, now, this Ramukannoya and Mutukandia. Mutukandia was a tributary of Hadoya, and that irrigable area, the beneficiaries were Bibile electorate. And that time the MP for Bibile was Jayawardhan Nattanayaka. He used to come to our office and all that. And he is apparently the Jayawardhan of Kataragama Devale, and he was influential enough to get the money allocated through the planning branch. Get the money allocated through the planning department, planning ministry, and got it. And whereas Ramukannoya was to irrigate 6,000 acres, and the MP was, it was coming under Ampara electorate. The MP was Senarath Somarath, the Deputy Minister of Irrigation. He tried hard to push it, but the acreage was big and the estimates were bigger. So he couldn't push it. And I understand recently with Mahinda Rajapaksa's government around 2030, they built the Ramukannoya. I'll show some pictures. And Mutukandia was completed, started around 76 or whatever, and they completed with Australian help, or Australian Assistance Bureau. I think they completed around early 80s, if I remember right. And so that was Mutukandia after completion. This was Ramukannoya. This is the ancient rock structure found in the vicinity of Ramukannoya. This is an amazing thing, you know. This is an, I don't know, please go and visit this place. These rocks are finely cut, and these are huge ones, you know, something like 10 to about 20 feet long and about 3 feet depth, or whatever the depth, and all joined. And underneath there's again hard rock, and it looks like double barrel. But apparently this was not completed, and no one has done any investigation into it. But now, actually, those who have been into England, these guys talk of Stonehenge and all that, and they call it a heritage site, and a lot of tourists go. But we should advertise and make our visitors to go there. We should advertise, and the people should visit this place. And amazing. I don't know. It has all these are how they were brought here. No one knows, and how it was cut to that size. No one knows. I just recently saw a video by somebody, and it's amazing. This is Ramukkanoya completion after restoration 2013. That's the Ramukkanoya. I call it Ramukkanoya, but these people call it Ramakanoya. So that's the sluice. And I was happy to see Ramukkanoya spilling in January 2017. And it was, as the engineer who did the initial inspections, surveys, and feasibility studies and feasibility reports, it gave me utmost satisfaction to see the reservoir spilling. You know, it's a treat to see a reservoir spilling and serving the mankind. So, you know, so it was a treat to see. And I somehow missed this. This is the statue of Gondravella Kapatipol Disave, the leader of the 1818 with the yeah, so this statue is found somewhere. Now, getting on to this little experience of experiences in the 1978 flood of Parakma Samudra. What happened was, this is the eye of the cyclone located at the east coast of Sri Lanka in 1938. Yeah. And cyclone was formed in November 20 and attained the peak intensity on November 23rd. Wind speeds of about 220 per hour. Due to the cyclone, approximately 1,000 people died and more than 1 million people affected. Nearly 250,000 houses partially destroyed. 28,000 acres of coconut cultivation in Batipur district destroyed. And now this is Parakrama Samudra, where, oh, sorry. Right. This one is, I said, joining three tanks, the Irrigation, wait, I had Thopa Weber, Irrigation Weber, and Dugutuli Weber. So this is maybe Thopa Weber, Irrigation Weber, and Dugutuli Weber. So it's single bank in channel and joining, right? And what happened was that particular day, the daily news front page was giving the helicopter shot, and those guys and the helicopter shot and water overtopping the bund. And Mr. Also Guruvardhan was the director. He called myself and Tilak Interpitia and said, showed us this and said, take a 4-wheel drive and go meet Mr. A.D.S. Guruvardhan, who was the IE Polonaru. We did, and also under Mr. Olson's purview, it was, he had some drillers of drilling by getting got caught to the floods at to whatever or somewhere, and then there were soil testers who had got who were working there. So we had to rescue some people like that, and the hydrology people like that. So anyway, we met the ADS, and that's the story. And what happened was, that's Parakrama of the bund, and water was going over the bund at few places, right? And we were there. Now, ADS was the IE, and Mr. Austin Fernando was the GA Polonnaruwa. And so this is a shot of Parakrama at full capacity. And what happened was, that's one top level, it's a high flood level, full supply level. Now, from full supply level, what's the difference between high flood is that's the flood lift. That flood lift is when if it is for 100-year flood, when a 100-year flood goes through the spillways, there'll be a general flood lift. And that flood lift added on to full supply becomes the high flood level. And then the difference between high flood level and the bund top level is where what they call the Rallapanawa or the riprap. The riprap. Riprap is actually something like they divide for the waves. Height of the wave and all that is by the, depends on the fetch and the wind velocity expected. So fetch is the probably the longest distance from one end of the water spread to the other, so that the wind, if wind happens to come that way, to which height the waves generated, and then about 1.5 times or something, and then we leave a gap and make to decide on the one top. What has happened is, purpose of the it was spilling over, waves due to wind overtopping the barn. So the situation was really serious, and 18,000 acres under cultivation at that time. And now Parakram Samudra has a catchment area of 28 square miles. That's its natural catchment. And the heavy rainfall was forecast by the meteorology, Colombo. Nothing specific, no figures given, heavy rainfall forecast. But we could control Amangaga, the inflows from Amangaga, we control. And so this one, heavy rainfall expected. And we can now, Mr. Edis Gunawardhan and then one option, if it breaks at the unwanted point of the King's Bund, now 9 miles long, and for some reason, if there's some lack of quality control in one of the King's area, had it, Kadruela or whatever the area downstream, homesteads will go. An unexpected place if it breaks. So in order to, one remedy is to get the bulldozers there to the sluice site or the dam site. These things are ready, but to cut open. And then the waterway is there now. So for the flood to receive, otherwise if it gets an unwanted place, that's the damage is very much. But we can't do it because 18,000 acres under cultivation. So then we won't be able to, if the water is drained out, if the tank is empty, then the farmers will cry. That's another issue. So we had to decide what to do. And eventually what we did was, around 10 o'clock in the night, now the crowd, Mr. Edis Gunawardhan, Austin Fernando, and crowd, we were, what to do, we thought, is to leave all the sluice gates open. That's Parakram Samudra with all 10 radial gates open. And then leave the sluice gates also open and see tomorrow morning what the outcome is, right? Because heavy rainfall forecast. But what has happened was, we went out, following morning we came, this was the result. The King's Bund of Parakram Samudra stood firm and withstood the flood. It withstood, nothing happened. But quality of the earth bund was very good. Full credit to King Parakram Bahu and his men. But a different engineering phenomenon was ended. Owing to sudden drawdown of the water table, slip circle failures occurred along the tank bund. I'll tell you what slip circle failures are. That's what that earth slip, because of the saturation, they can't hold the thing and it slips down. And this has happened for quite a distance of the 9 miles. So the irrigation department has to redo it. Though the water was saved and the crop was saved, but it's a reconstruction of the dam. And what happened was, meteorological prediction of rainfall did not happen. That was expected rain didn't come. And because of the sudden drawdown of the water table, this slip circle failures occurred. Now, this is interesting. Now, this is interesting. What happened was, this Colombo, Belangville, all over, the jogging tracks, it was very popular and all that. So what happened was, I think Namal Rajapaksa thought good idea to start introduce the jogging track at Parakram Samudra, and Roshan Ranasinghe, the MP, all welcome, and they wanted to do it. The funds, and well, this is what we managed to get the particular sketch and probably this was not a engineer design drawing. Some draftsman would have done this. Anyway, whatever it is, they wanted to introduce probably a jogging track disturbing the King's Bund. What happened was that's the bund, and they had drawn some yellow lines, and anything on top, the riprap, was rolled down to the tank bed. I managed to get some photos from Lanka. So this is what they were rolling down the thing. And that's they were rolling down the thing, and they were happy to put the jogging strip there. And this is what the dismantled thing is, dismantling of the Palako Samudra. So, yes. And what happened was, we wrote Tilak Nikapitiya, myself, Mr. A.D.S. Gunawardena, and Austin Fernando. We wrote a PSU report. We send it to Irrigation Ministry, and we try to, we managed to show it to Mr. Sirisena. He was just an MP. He was not the president. He was just an MP for Polanaru, and probably he would have had this thing against Roshan Ramsega. So that's but we explained it to Sirisena, but nothing happened. Then we wanted to show it to explain it to Minister the Chamal Rajapaksa, but it was not successful. And Gotabaya Rajapaksa was inaccessible. But what happened is, luckily or unluckily, country got bankrupt. Right? Luckily or unluckily, country got bankrupt. So the money was stopped. Stopped. And then, so we said, our argument was, if you leave it like this, don't leave it. If a 1978 flood comes, this will be gone. So please put back the riprap back again. I don't know. Janaki says it has been put back. So if it is the case, well and good, right? Then this was again. I think. Excuse me for. I'm just saying what my feelings were. There was a minister in this happened in probably my recollection 1985 or 86 or whatever the period, and Minister of Local Government and Water Supply was who, and he was the Prime Minister. He eventually became the President, and he is a person where he doesn't want to take any instructions from anybody, and he thinks he knows his engineering, right? And he used to give instructions to various people. And if he decides, I want to have this here, and he won't listen to anybody, and he gets it done. So some or other, he has wanted to install a pump house at Kansale on the King's Bund. And as you know, when pumping starts, there's a jerk. When it stops, there's a jerk. And they have allowed heavy vehicular traffic, Prima and all this heavy traffic on the King's Bund. And there would have been generated cracks and all that. And eventually this resulted. And amazing part is they have driven, I don't know, this would have been, who did it, Water Supply and Drainage Board maybe. I don't know, that's their project because Mr. Premadasa wanted to supply water, Kansale tank water to some Kansale town or Trinco, I don't know. So, but they have driven piles and driving piles on soil. I don't know. So that's the problem. And there's another shot for the pile. And controversy, yeah. But this person, I'll tell you, he was Minister of Highways as well. A friend of mine was telling me, when the road takes a bend, and if you're going at 60 miles per hour, and then there's a chance for the car to get shifted away because of the centrifugal force. And the standard way of highway construction, we used to put a camber or super elevation onto it to balance the weight component and all that. So Mr. Prebadas had the habit of inspecting construction sites under his purview, and he stops. And that particular day, he has come and checked and said, "Mahatya, ko me engineer Mahatya, මේක වතුර මේ පාර level නැහැ. දැන් මම යනවා පැය තුනකින් ආපහු වෙනවා මේක level කරලා දාන්න." Then, site engineer. So site engineer has come. You know what he has done? He has called the bulldozer guy. I said, "ඔක්කොම level කරලා දාන්න." Then but then these guys said, "I said, අපි අමාරුයි කළේ." නෑ අගමැතිතුමාට ඕනේ මේක ඔක්කොම level කරලා දාන්න. ඔය centrifugal පැත්තක දාන්න ඔක level කරලා. And this is what the politicians do. And even lately, there have been a politician who have been saying oxygen kandada. Oxygen kandada. Right? So anyway, that's that. Now I'll just run through Mahaveli development. This is the map of Mahaveli. What I managed to get in 87. I'm talking of modern development is that. That's Kotmale, and there's the upper Kotmale, not in that in 87, but it came up. And then Polgolda, and then the Subuganga, power generation at Ikuela, 40 megawatts, and coming and to Bovatana, and from Bovatana, we can get to Kalaveva, Kandalama, all this, Kalaveva, Radangana, Kalaveva, it speaks Radangana, and then the Nuchiagama, all this, whatever, and this way, it's going. Yeah, but you all know it. I'm just coming to it. You know, whatever. And then from Bovatana, it's among other diversion, and then Givitale main area, and then Kaudula, all this, and then further down, it goes that way. Alle Kamsale, Mahaliganga, all this. And from here, it's Polgola, with Victoria, Randavigala, all this. And then the Umayyas have come up and all that yeah, and then we have the Minipe LB there, and the Minipe RB, we have 3 crossings, you know, the Baduloya, there's a Fidak, the Logaloya, Pepoloya, and Diapana. In 1978, I could remember we were in Hyderabad. The Logaloya was, I think I did the design for the 100-year flat hydrograph. Anyway, and it's coming to Uliti and Ratkida, and that channel taking to Madhuroya. And these ones, you know, Logaloya, Hepola, and Diabana, they were level crossing sites in the zigzag, the labyrinth spillways, they are quite nice, you know. And even Pidurakta getting more Mahaveli waters, they introduced this riprap labyrinth spill, and that's a popular bathing spot. Going down. That's that. There's a more elaborate one. I think we should be able to run through it, and you all know all about it, but for complete. So my modern development stopped at 1987. I don't know. These recent ones are not included. All this, you know, Moragakanda and all these are. This is what I managed to. That was the up to 87. Thank you.
Thank you very much, Engineer Paditha sir, for that enlightening and inspiring presentation on ancient irrigation systems in Sri Lanka and their modern development. We will now move on to the discussion and question and answer session. May I kindly request Engineer Paditha to take a seat at the head table for this session. Yeah. I now invite the audience to actively participate by raising your questions, comments or observations, kindly introduce yourself before asking your question.
Katasorovar, Visokoto was an extension of Katasorovar, right? The diagram you showed where the Visokoto is in the built in the dam, which is not correct, no? Because the Visokoto is not in the dam, he's in the like in the Katasorovar is inside. It is not on the dam. So we said it is a weir, not a sluice, because like a Katasorovar, to the planks, one by one, you are removed. So it is actually a Katasorovar, a large Katasorovar, but it is not in the bank. If you show the slide, I'll show you what the problem with the slide is. That slide there shows the.
Yes, yes, I'll cover. This one? Oh. Oh, yeah. Yeah. Yeah, 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 yeah. Uh-huh. I see. Yeah, 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 yeah. Mr. That may Palay. Yeah. No. That one.
Yeah, right. Yeah, thank you. Yeah.
Yeah.
So this top, it's a Katasorovar. Like a Katasorovar, you can remove the first rectangular section.
Yeah.
So like a cafe.
Yeah.
One by one.
Yeah, but these are at high height.
Yeah.
30 feet.
They had structures. No, I think this is, I'm not a.
Yeah. We are also guessing because we don't know.
You can have a chat with your friend, Vanchi. He had done something, he had been a color. He's the one who came up with this idea. And
Dr. Ranjit, yeah.
Have a look at it.
Yeah, sure. Thank you. And that here, gamma. Sorry. This one. So you reckon it is to be?
No, say look at the Katasorovar. Yeah, the other Katasorovar is.
Yeah.
And as the water level recedes, you remove the container.
Yeah.
Right?
Yeah.
So now imagine.
You remove the cafe.
Yeah, you imagine. Lokoto is a large Katasorovar.
Right.
Huge one.
Okay.
And what do you remove? You remove the first rectangle. And for that they had structures to remove. So it is a mixing. It's not in the dam. It's not never in the dam. You can see any Visokoto drawing. So never in the dam. These things grow here.
Yeah, grow here.
Thanks, Pancha. It was very good explanation. But my question is not to Mancha, to somebody here who is currently in the irrigation water management. That is, these ancient dams, we don't know how these were built, but presently the disaster management, I don't know whether we have a system of getting, I know irrigation department those days had soil testing and lot of records. Whether it has been continuously monitored, the large dam, 9 miles long, getting the core samples, core water pressure measurement, and see how it behaves So we don't have another disaster. Like Hantale, it was man-made, I know. But then, because ancient ones, we don't know how these were. Because I know some places, I know New Zealand, we had a situation where rail track that was built in the around 1900. So around 1990s, they built not a reservoir, maybe flood protection thing, dam. In that, I was in there. The four samples are taken, but you can't rebuild it because you don't know how it was done with various rubbish being put and they are compared to railway. But they have system of monitoring the water pressure, the piezometers about 40 or 50, which are being monitored after rainfall 50 millimeters over a 24-hour period. Then you get the SCADA things, which after that you go and inspect those. The SCADA system is there, level measurements. Anything more than 50 millimeters, that is a reasonably high rainfall, you go and physically look at the thing for cracks and things. And there were culverts where minor cracks were being photographed annually. That type of system was there to prevent a disaster. Now, with our dams being so big and any breach, the settlement people downstream is disastrous. Whether we have anything, I know irrigation department that time, we had a system of records and soil testing, but there, Shelter Fernando, Dr. Vignesh, at that time, my involved in Mahavali ended in 1975. But then I don't know how good it is because some of the thing, one is that, other one is the structures. Somebody told me there are a couple of buildings in Colombo which are about 40, 50 stories abandoned. So that type of thing is a real be a disaster if something happens. So if someone from here can sort of enlighten us, where are we heading? Thank you.
I think there was around 2007, there was a World Bank pre-feasibility to check some safety of dam. There was a subcommittee and people were involved in it. Subcommittee where this they were checking the structural stability and all that. I'm sure they may be doing something, but I would like to add that Parakram Samudra, what happened was on the top, there were there were cracks developing on Parakram Samudra because it's two-way traffic and they allowed heavy vehicular traffic to move around on the Parakram Samudra Band. What happened was these guys trying to do this jogging track. What they should have done was take some tins of paint and draw a line at the continuous white line at the center and say this half is for joggers, other half one-way traffic, easy. That, but then they want bigger estimates and bigger whatever commission. Yeah, and I should add, they should treat King's Bund with respect. They mustn't interfere to King's Bund at all. This is what happened to Kantale and Parakram Samudra. There are so many. We have to treat it with respect and mustn't interfere. That's my view. You know, we don't know how the king has made this. You know, because you can't just stamp. You have to add water and stamp it, and all these procedures, soil mechanics. King's soil mechanics, but it has. We only know existed all these years, number of years, or whatever. So we expect must interfere, review. Any comments from Irrigation Department or Karu or? Yeah. Yes. You were involved. Yeah. Yeah. Yeah, Mike.
Yeah, do holes and also introduce some meters and all that sort of thing, some automatic level measurement
Yeah.
also. I don't know what happened afterwards. That came away.
Uh-huh.
I was very
So
pleased.
that was pre-feasibility, I knew. After that, that
No,
continued.
there was a project. There was a biggest project for dam safety. Some police or some other.
And I know Dr. Sunil, Professor Sunil Wickramasuriya Katubedda, he was there, Gamunu Silva,
think so.
Dhammavira Kon, and all these people were in
There
that
was a
committee.
bit of work that been done.
Ah.
But that really should have continued because it's not something you do and go away.
Yeah, that's
It's
right.
a continuous thing that has to continue.
Yeah.
I don't know what is happening. I had just had associated with that. Sorry, what I
Yeah,
mentioned.
yeah.
And I also want to mention about the Kantale.
Kantale, yeah.
Because we were doing the treatment plant,
Uh-huh.
water treatment plant,
Uh-huh.
right?
I see.
And at that time, it was Conrad.
Yes.
So very, very upset
Uh-huh.
when they decided to do it, the farmhouse in the dam.
Dam.
They don't do it.
Uh,
They predicting this.
So Mr. Ponraja said, don't do it.
Yeah, God, yes, yes.
And then what happened? What Prime Minister was more powerful.
Yeah, exactly.
Yeah. And he's a man, if he decides, want to have a palace being built here, I want it. That's
Exactly,
it.
exactly. Yeah, you
So-
typical thing what you are saying.
Yeah.
Well, I don't know whether the same things are happening now
Yeah,
also.
yeah.
So,
Yeah.
Thank you. It's a very interesting and very nice lecture. Thank you for delivering that. Can you please put on that Kantale Breach? Yeah, that one. Now, you see some rocky structure. What is that? Is it a name?
This is actually, I got these two photographs.
Because
from
inside the
that
dam,
period. Huh?
inside the earthen dam, such a structure is something very peculiar.
Huh?
Could have been all sluice or something.
I don't know.
Sorry?
Come.
This rocky rocks?
It's open for discussion.
Yeah, that's what I'm asking. No, not the riprap. Riprap is on the top of the dam. No, riprap is on the top of the dam, no? And it's in the
I think this is the
it.
sluice structure, all sluice structure.
Something very special there
Yeah.
because
Or the abutment of the something like it.
We have to, Tilak Likupitia gave me this, so. Karu, you have any comments?
Couple of comments because I'm a man from Polonnaruwa.
Right.
On the particular day of cyclone, I was in Polonnaruwa. I was irrigation engineer attached to CI's office. ADS was IE Polonnaruwa. I think drawdown, I don't know whether the slip circle failure is due to drawdown or otherwise. What really happened was immediately after the cyclone day, we went to see the dam. There's little overtopping in some places, but what happened was the riprap was taken inside the reservoir with the wave action. Right? That is how it got covered. There's one comment. The other one, when we were reconstructing the dam during various time, and we found what you call the Silalekana, stone inscription, which was inside the dam, which says that King Parakram Bahu constructed this structure. other comment I have is that there is no so-called king's bund. Right? My feeling is that reservoirs are built between two hillocks. Right? Though it is 9 kilometers long, natural ground is at least about 3 to 4 kilometers.
I see.
Because you see from the ASP's bungalow up to GS bungalow, that's a natural ground.
So that is under the Topa Weber.
Yeah, exactly. Just after Topa Weber, you have the natural ground, and these natural grounds are connected with the constructed dam.
Okay, okay.
And other observation
But
I
you
have.
agree that it's a single bank in
Yeah, it is. People consider it as a single.
banking
level
pool.
Yeah, dam. Other one is most of these reservoirs are built on quartzitic band. You know Sudukanda. Even Giritale, just opposite Giritale is Sudukanda. And you can see the bottom structure, if you see, it is starting from Kirindioya up to India. That quartzitic band is going. I think if you refer to Professor Vitanagi's geological mapping, you can see most of the dams are constructed on this. The other school of thought of the Kantale failure is the poor water pressure.
Poor water.
Because when the poor water pressure builds up, it's like a bomb, right? It happened in, what do you call, Pekulam. There's a small tank. During that period, I was in charge of construction of the sluice, and the Pekulam Dam, there was a section which we built on the quartzitic band. We didn't remove the quartz. We built the dam on that one, but there was a small leak. After that, it get exploded. And I think there is some people are talking about this pile driving and all sort of things cause this damage. But my other way of thinking is the poor water pressure is a very dangerous animal. If you want to think about the dam safety, you have to release the pressure. That is why you have chimneys and blankets and the tow filters, right? You can see Kirindiyo Dam. We have a very nice tow filter. We have a very good blanket and the chimney. It was very well done. I think that's one of the best construction done by local engineers. I think many more things to comment, but it takes time. I'm sorry.
I can remember Dr. Bala Subramaniam, our lecturer, Dr. Bala, when we were doing the coursework and all that, it was actually, he was telling us in detail, you work out, divide it into thin slips, and each of those, that poor water pressure you were talking of, and then it can't sustain it because that's a natural tendency. So that's why even on the road, if you see a earth slip, he was talking about, he said, watch for these slip circle failures. So Bala was doing that. So thanks to him, when we saw this the following day after the flood, I was telling ADS, this is slip circle failure. Because it can't take up the poor water pressure so high that, it slips. So thanks to Bala. So I straight away said, thanks to Dr. Bala Subramaniam. He's now in somewhere in Queensland. Yes.
Is there any evidence that in the King's period had any dam breach? In King's period had any dam breach situation? Is there any evidence?
Yeah, because all these tanks, what irrigation department restored is owing to some major flood one day or other and gone. So
in those periods, how they handle this situation and no.
It's anybody's guess. And the other one was saying about that. I think I'm sure this water dam safety committee would have resulted in better use of it. I'm sure. Yeah, I know. Right. Exactly. Even 78 flood, we were concerned if it breaks at an unwanted point. Here, see the damage. It was a critical situation. Actually, in that 78, then in 79, I went out to school to Australia with the civil. We were back with the force. I offered the subject economic feasibility, economic of dams or something. I presented the case study on this, and David Havel, professor, he was shocked to see. He was really interested to hear about this case study because this is a composite thing. It's not wave. It's not releasing water, but there are some social things. The public. We have to safeguard the public. Everything. So it's not a easy thing, but these guys now say, why didn't you release the water?
There's another point, Palita, I would like to mention. I was lecturing at the tourism college for the chauffeur guides and the national guides on ancient irrigation and modern irrigation. I think ADS was doing it before. When he said, I can't do it, then I had to take over and I started doing it. There I started reading the Ceylon history and R.L. Brohier. You can see the Brohier, the present Mineria system or Alahara system, if you take all that is up to Kantale, all that is in the R.L. Brohier's book. And on the way to Kantale, it feeds Protovava and Talakolava and small tanks. That system was there. Even the Angamadilla was mentioned in R.L. Brohier's book. I think since you are doing little research, but you can parallelly read your historical guidance as well as the R.L. Brohier's findings. And it is that there is another one thing that it was said like this. දැන් අපි කියනවානේ මේ මම සිංහලෙන් කියන එක හසෙන් වැටෙන එක බිඳුවක්වත් මූදට යවන්න දෙන්න එපා කියලා පරාක්‍රම බහු රජුරෝ කිව්වා කියන එක විතරයි දන්නේ. In IWM or MI also International Water Management Code that is there, it is printed there, right? And what I am saying is in that R.L. Brohier's book there was an inscription translated to English by Mudlier Mendes for R.L. Brohier. It says, don't cultivate rice in precious lands, land covered with, this is Parakram Bahu's statement. At the bottom he said, let not allow a single drop of water go. Because Parakram Bahu has given a very nice, what you call planning exercise, so planning directions to his ministers, how they should plan it, where to cultivate rice, where to have the gems, where to have the rock, and all that is being very well described in that R.L. Brohier's book. Just for your information.
And just another thought, now people like senior people, Cyril, and now Janaki and all that, additional Director General. Just the thought came to me about this one tank, one village ecology. Can't we have it establish that? Because it's easy, no control. Rains come, stored up in the small reservoir. Downstream where we have the paddy lots and homestead, and that's one complete unit. Another unit. Can't we go back to that? I don't know. I'm just
an observation.
Yeah. Yeah.
But I was Expert, I can think aloud, no? Right?
Yeah.
No, what I'm saying is that if that was the way it was constructed, the pond, then it is connected to another pond. That's what you said, no? Another. So I would say Jayaganga is a long reservoir. Huh? Is that correct?
Yeah, but this is actually the water is flowing, but we need the water surface elevation.
Water the hydraulic gradient because you have the gradient from the soil flow.
Yeah.
Right? And you can create the hydraulic gradient. You can fill the water that side and close everything. That is called hydraulic gradient. Diagram is the concept of hydraulic gradient.
It's again, but the basic difference diagram is against the contour. Whereas
Yodala is along.
But for KYE, it's moves along the contour. Other one is at right angles to the contour.
I want to ask a question, Mr. Bhatt. You mentioned about the large number of small tanks in Ua, right? Now, even now, Monrado and your cases have this problem of even drinking water.
Yes.
So I was wondering whether those things aren't those the small tank we resurrected now.
Yeah.
That will to a great extent solve the problem because and your weather pattern. I have studied that contract, but exactly what is happening. There's so many months of dry weather and you need to months of this thing. But during the time, every time they will complain no water, not even drinking water. So obvious answer was there already. So people must look at it now.
Just one observation and one suggestion. The observation is similar to Vaharkade. I was working at Inginimitia. Inginimitia also, when we were digging the spill, we found the old Madasoro.
Right.
Now this word Madasoro is not used much now. But as far as I can understand, Madasoro would have been on the small water course, which would have been dammed to make the reservoir. There would have been some small water course which would have been dammed to make the tank. So that is really the lowest point of the tank. And I think, so that means each of these, even village tanks, will have today a Madasarova buried so many feet under the ground, which we have forgotten. It's only when digging for the spill that we found that out. And I remember we gave it to that Ngirimitia, and it was handed over to the temple which was there.
Right. That's the one.
Yeah, that's the one.
Yeah.
Yeah.
You're right.
Yeah. And just one other thing, small thing. I think if you take the 1-inch maps, if you take the Buttala map, there's hardly any village tanks marked on it in Buttala. Yeah, in the 1-inch sheet. But in just the southwestern sheet at Tingolgati, I think there is one of the highest densities of tanks.
Right.
I think most probably, I have been asking this question from irrigation engineers, nobody has given a direct answer why that is so. I think that is something to do with the 1818 rebellion, where they knocked off so many tanks, but they didn't want to put it on the maps later on when they map. I think. Because otherwise, there is no logical reason why the next sheet should have an abundance of tanks, whereas the Buttala doesn't have tanks. And my suggestion is, now all these things, especially for the young engineers to study, now we don't have the 1-inch maps. No, you can't. 1-inch maps have not been published for the last 50 years. Only the 50,000 is not there, and the 50,000 hasn't got half these old details which the 1-inch has. So I think if we are to get the younger generation involved and interested in these things maybe at least on a digital format should be available. Maybe where we can overlay the 1-inch on the existing 50,000 layer, and maybe at the the Mahavali schematics and things, which is just a line drawing, onto these things. Only then can the young engineers get the feel of what has happened and to plan for the future. I think that has to be one of the top priorities where the government agencies have to get together and do. Otherwise, we will just keep on losing information and making wrong decisions in the future.
Any comments for Jalvi?
No, I cannot.
Whether I have inspected velocity when I was doing 1 day and multitude of dependent and too much. It is very lesser. Some people say very large. 100,000 penicillin. In that thing.
Just one comment from my regarding this what Yodalas. There was a kind of an idea that Yodalas were just joining few independently located tanks. I think it's not the case. Yodala is a single contour canal which is going, which has only one bund. The other side could be a higher land or sometimes a saddle-like thing. When you meet a saddle there, it becomes a reservoir because the water spread becomes higher and higher. So that way you find along the canal you create reservoirs. So those are the ones which we now think we have joined. It's not the case. It's due to the bund only those reservoirs have been formed. So the leveling has been a very serious issue for that canal. It's not the joining of existed reservoirs. Those reservoirs are created by the bund.
Oh, good.
Thank you very much, all of you, for actively participating in the Q&A session, and Engineer Palitha for engaging humbly in that session. So we have already arranged a special token of appreciation for today's distinguished guest speaker. To receive this gesture of gratitude, I cordially invite Engineer Palitha Manchanayaka back to the stage. And to award the token of appreciation, it is my great pleasure to invite Engineer Karunasena Hettiarachchi, Senior Engineer and former Secretary, to the stage. With that, we have now come to the conclusion of today's program. On behalf of the IESL Water Forum, we extend our sincere gratitude to our esteemed resource person, Engineer Palitha Manchanayaka, for his brilliant and insightful address on ancient irrigation systems in Sri Lanka and their modern development. Thank you, sir, for sharing your expertise with us today. We also convey our thanks to members of ISL Water Forum, including our chairperson, Engineer Janaki, and for organizing this timely important lecture. Our appreciation also goes to the Institution of Engineers Sri Lanka and all the organizing staff and volunteers for making this event a great success. Finally, thank you to all the participants and invitees for your presence and attention, and all the Zoom participants for joining the session today online. We hope you found today's session both valuable and informative. Thank you all. I wish you all a very pleasant evening. Thank you and have a safe journey home.